Okay, next question. Do this. Verify the theorem proved above for p is equal to 2, p is equal to 3, p is equal to 5 and p is equal to 7 for a square is equal to 1, 4, 9, 25, 36, 49, 64 and 81. Now we have to verify. So to verify that one, let us take one table and write here a square p is equal to 2, p divides a square, p divides a. So write the values of a as 1, 2, 3, 4, 5, 6, 7, 8, 9 and a square values. What is 1 square? It is 1. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64 and 9 square is 81. So p is equal to 2. So here p is 2, 2, 2, 2, p is equal to 2 and p is equal to 2. Okay. Next p divides a square. So 1 divided by 2, it's no. 1 is not divided by 2. Next 4 divided by 2, yes. 9 is divided by 2, no. Next 16 is divided by 2, yes. Next 25 divided by 2, no. Next 36 is divided by 2, yes. 49 divided by 2, no. Next 64 divided by 2, yes. And next 81 divided by 2, no. Okay. Now we have to check whether p divides a or not. So what is p value? A, p value is 2 and a value is 1. So 1 divided by 2? No. Is 2 divided by 2? Yes. Next 3 divided by 2? No. Next 4 divided by 2? Yes. Next 5 divided by 2? No. Next 6 divided by 2? Yes. 7 divided by 2? No. 8 divided by 2? Yes. And next to 9 divided by 2? No. So this is a verification table for a square is equal to 1, 4, 9, 16, 25, 36, 49, 64 and 81. In the same manner, now we have to write the table for p is equal to 3 and p is equal to 5 and p is equal to 7. Okay, students, next verify the same theorem for p is equal to 3. So to verify, we have to draw the table and name it as a square, p is equal to 3, p divides a square and p divides a. So for that one, consider a values 1, 2, 3, 4, 5, 6, 7, 8, 9. Next 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64 and 9 square is 81. So now we are verifying for the value p is equal to 3. So you write here 3, 3, 3, 3, 3 till 9 threes. Okay. Next p divides a square. Whether a square is divided by 3 or not, we have to check. So what is a square here? 1. Is 1 divided by 3? No, 1 is not divided by 3 or 3 does not divide 1. Is 4 is divided by 3? No. Is 3 is divided by, sorry, is 9 is divided by 3? Yes, 9 divided by 3 or 3 divides 9. So if divides, you write yes. 16 divided by 3? No. 25 divided by 3? No. 36 is divided by 3? Yes. 36 is divided by 3. 49 divided by 3? No. Next 64 divided by 3? No. Next 81 is divided by 3? Yes. So in the same way, now we have to check whether this p divides a or not. So what is p value? 3 and what is a value? 1. Is 1 divided by 3? No. Is 2 divided by 3? No. Is 3 divided by 3? Yes. 3 is divided by 3. Is 4 is divided by 3? No. Is 5 is divided by 3? No. Is 6 is divided by 3? Yes. Is 7 is divided by 3? No. Is 8 is divided by 3? No. Is 9 is divided by 3? Yes. So this is the verification table for P is equal to 3. Okay, next now we have to verify for P is equal to 5. In the next question, same question, but first we proved for P is equal to 2, next we proved for P is equal to 3. Now we are going to prove for P is equal to 5, right? So take the table and mention a square, P is equal to 5, P divides a square or not, or P divides a. Right. Write the values of a 1, 2, 3, 4, 5, 6, 7, 8, 9 and the square of these values. A is 1, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64 and 9 square is 81. So let us write the value for P. Now we are going to check or verify for P is equal to 5. So write here 5, 5, 5, 5, 5, 5, 5 and 5. So P divides A square or not. Whether A square is divided by this P value, that is what is P value? 5. Is 1 divided by 5? No, it is not divided by 5. 4 is not divided by 5. 9 is also not divided by 5. No. 16 is also not divided by 5. 25 is divided by 5. Yes. 5 divides 25. 36 divided by 5 or no? Is 49 divided by 5? No. 64 divided by 5? No. And next 81 is divided by 5. So that also not divisible by 5. Now we have to check for P divides A. Whether P divides A or not. So what is the value of A? 1. And P value is 5. Is 1 divided by 5? No. 2 divided by 5? No. 3 divided by 5? No. 4 divided by 5? No. 5 divided by 5? Yes. 5 divides 5. 6 divided by 5? No. 7 divided by 5? No. 8 divided by 5? No. And 9 divided by 5? No. So this is a verification table for P is equal to 5. Okay. Okay. Next we have to verify for the value P is equal to 7. So we proved or we verified for value P is equal to 2, P is equal to 3, P is equal to 5. Now we are going to verify for the value P is equal to 7. So the same table, write A values, A square values, P is equal to 7 and we have to check whether P divides A square or not. Next P divides A or not. So write the values of A 1, 2, 3, 4, 5, 6, 7, 8, 9 and A square. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64 and 9 square is 81. Okay. Now we are verifying for P is equal to 7. You write the value 7, 7, 7, 7, 7, 7, 7 and 7. Now check it. P divides A square or not, or whether A square is divided by P or not. So what is A square here? It is 1 and P value is 7. Is 1 is divided by 7? No, there is no possibility. Next, is 4 is divided by 7? No. Next, 9 is divided by 7? No. 16 is divided by 7? No. 25 is divided by 7? No. 36 is divided by 7? No. 49 is divided by 7? Yes. 7 divides 49. Is 64 divided by 7? No. 81 divided by 7? No. In the same way, P divides A or not. So what is P value? 7. What is A value? 1. Is 1 divided by 7? No. Is 2 divided by 7? No. Is 3 divided by 7? No. Is 4 divided by 7? No. Is 5 divided by 7? No. Is 6 is divided by 7? No. Is 7 is divided by 7? Yes. 7 divided by 7. Is 8 is divided by 7? No. Is 9 is divided by 7? No. So this is the verification table for P is equal to 7. Right students, next exercise 1.4, first question. Prove that the following are irrational. Question is 1 by root 2. Now we have to prove that 1 by root 2 is irrational. Okay. So to prove that one, first of all, we have to go in indirect method. That is, let 1 by root 2 is a rational. Let us go in reverse order or indirect method, not in a direct way. So we have to consider let 1 by root 2 is rational. So as we know that according to the definition of rational, we can write 1 by root 2 is equal to a by b. Rational numbers are represented in the form of a by b or p by q form. Okay, right. Next, we can write this as, or simply if we replace numerator by denominator and denominator by numerator, so we get root 2 by 1 is equal to b by a. Okay, root 2 by 1 is nothing but root 2, that is equal to b by a. So in LHS, we know root 2 is irrational. Root 2 is irrational. Okay. Now in RHS, A comma B and B by A are integers. First of all, they are integers and they are rational. Okay. So in LHS, we know that in LHS root 2 is irrational. In RHS, we have AB and A comma B and B by A are integers and they are rationals. All integers are rationals. So LHS we are getting irrational and RHS we are getting rational. It means that our assumption is wrong now. So what we assumed or what we considered, let 1 by root 2 is a rational. Therefore, our assumption is wrong. So we considered, so what we considered 1 by root 2 is rational, no? So that is our assumption. We consider that 1 by root 2 is a rational. So our assumption is wrong. If our assumption is wrong, then what is correct? Hence, 1 by root 2 is irrational. So we assume that 1 by root 2 is rational. That is wrong. If that is wrong, then what is the answer or what is the correct one? 1 by root 2 is irrational. That is the correct one. Okay. So this is a proof of 1 by root 2 as a irrational. Right. So next question, first bit, second one, prove that the following are irrational. So here the second question is root 3 plus root 5. We have to prove that root 3 plus root 5, but we know that root 3 and root 5 are already irrational. So once again we have to prove that they are irrational. So to prove that root 3 plus root 5 is irrational, so let us consider or let us assume root 3 plus root 5 is rational. Let us go in indirect way. Students, to prove this is an irrational, so first of all we have to consider the given as rational. Okay, as per the definition, we know that root 3 plus root 5 is equal to a by b. Rational numbers are denoted, rational numbers are represented or expressed in p by q form or a by b. So here I have written a by b. Now what we have to do is, so you keep root 3, either root 3 or root 5. So place this side and transform one of the term, that is root 5, to that side, to RHS. Root 3 is equal to a minus b root 5 divided by 5. Now squaring on both sides. Squaring on both sides. So what happens? Root 3 whole square or root 3 square is equal to a minus b root 5 by b whole square. Here square and root cancels. 3 is equal to a minus b root 5 whole square divided by b square. In the next step, take a cross multiplication. 3b square is equal to a minus b root 5 whole square. Okay. Now 3b square is equal to, expand it. What is a plus b? A minus b whole square formula? A minus b whole square formula is a square plus b square minus 2ab. So this is a formula. Now expand this one. 3b square is equal to a square. What is a square? A square only. plus b square. What is b square here? B is nothing but b root 5. B root 5 whole square minus 2ab. 2a. A is a only, b is b root 5. So that is equal to 3b square is equal to a square plus, here we have two terms inside the bracket. So it means b square root 5 whole square minus 2 root 5 into a into b, ab, right? 3b square is equal to a square. Square and root cancel here. A square plus 5 into b square is 5b square minus 2 root 5 ab. So in the next step, replace or transform this part to this side and 3b square to RHS. So what happens? So here it is negative. If I bring to LHS, it becomes positive. 2 root 5 AB is equal to a square plus 5b square plus 3b square. Transform to RHS, it becomes 3 minus 3b square. So 2 root 5 AB is equal to a square plus, from 5b square if we subtract 3b square, we get only 2b square. In the next step, just you write here root 5, that is equal to a square plus 2b square. Remaining will go to the denominator, that is 2ab. Okay, root 5 is equal to a square plus 2b square by 2ab. In LHS, root 5 is irrational. We know that root 5 is irrational. Okay, whereas in RHS, so terms are a comma b comma a square plus 2b square by 2ab are integers. Integers and rational. We know that all integers are rationals. Yes or no? So in LHS we are getting irrational, in RHS we are getting rational. Therefore, LHS is not equal to RHS. Our assumption is wrong. Our assumption is wrong. So what was our assumption? What is our what was our assumption? Root 3 plus root 5 is rational. That our assumption is wrong. If our assumption is wrong, then what is the correct one? Then root 3 plus root 5 is irrational. That is the answer. Next, first bit, third question. 6 plus root 2. Prove that 6 plus root 2 is irrational. So same method follows here. Let 6 plus root 2 is a rational. So if it is rational, what is, according to definition, we write 6 plus root 2 is equal to a by b. Okay. So I write root 2 in LHS, a by b in RHS, and transform this 6 to from LHS to RHS. Here it is plus 6. If I transform to RHS, it becomes minus 6. Then root 2 is equal to a minus. Take a cross multiplication here. 6b by b. So in LHS, root 2 is irrational. That is, that thing we know that one, root 2 is irrational. Next, in RHS, a comma b comma a minus 6b by b are integers. All these are integers only. What are they? A comma b comma a minus 6b by b are integers, and we know that all integers are rational. So in LHS we are getting irrational number, in RHS we are getting rational number. Therefore our assumption is wrong. So what was our assumption? 6 plus root 2 is a rational number. That is wrong. Therefore, hence we can say that 6 plus root 2 is irrational. That is a proof. Next, fourth question. Prove that the root 5 is irrational. Already we know that root 5 is irrational. Once again we have to prove that root 5 is irrational. So to prove that one, let us prove, or let us go in a indirect way. So let us consider root 5 is a rational. Root 5 is a rational number. So that is root 5 is equal to a by b. Then root 5b is equal to a. Right? Next, squaring on both sides. Let us square on both sides. Square on both sides. Right? So root 5b whole square is equal to a square. So in the bracket we have two numbers or two what is that terms. One is root 5 and one more is b. It means root 5 square b square is equal to a square. Square and root cancel. Then we get 5b square is equal to a square. Then b square is equal to a square by 5. So we have one statement. What is that statement? By a statement, if 5 divides a square, then 5 divides a also. So here 5 is dividing a square. Just now before this proofs, we verified p value is equal to 2, p value is equal to 3 and p value is equal to 5. So in the table we verified all these things. So by a statement, if 5 divides a square, then 5 divides a also. Okay. So consider this as equation 1. So in the next step, we have to consider let a is equal to 5c, where c is any integer. Okay. So what we have to do? We have to consider or we have to assume let a is equal to 5c. If the question is about root 5, then we have to take here a is equal to 5c. If the question is about 2, root 2, then we have to consider or we have to assume a is equal to a is equal to 2c. Okay? Right. Now substitute 2 in equation 1. So what is the equation 1? B square is equal to a square by 5. And what is equation 2? A is equal to 5c. So substitute 2 in 1. So that is b square is equal to a square. Instead of a, we have to write this 5c. It consists of square. Then you write square divided by 5. Okay. So b square is equal to 5 square c square divided by 5. So 1 5 and 1 5 gets cancelled. B square is equal to 5c square, or b square by 5 is equal to c square, or simply we can write c square is equal to b square by 5. Okay. So say once again by statement we can say that if 5 divides b square, 5 divides b square, then 5 divides B also. Okay. So in the beginning, we considered root 5 is equal to A by B, where one step I forget to write here, where A and B are co-primes. Where A and B are co-primes. Okay. Next. So by this, what we understood? Therefore, 5 divides both A and B. Look here. 5 divides A, 5 divides 5 divides B. 5 divides A and 5 divides B. So therefore 5 divides both A and B. But in the beginning we consider that A, B are co-primes. Only one factor, that is only one is the common factor for both. But here we are getting 5. Therefore our assumption is wrong. Our assumption is wrong. Hence, root 5 is irrational. So if our assumption is wrong, then the given question is correct. Root 5 is irrational. Question in the first bit, prove that the following irrational, that is 3 plus 2 root 5 is irrational. So we have to prove that 3 plus 2 root 5 is irrational. Let 3 plus 2 root 5 is rational. Prove in indirect way. Consider 3 plus 2 root 5 is rational. That is, according to definition of rational, 3 plus 2 root 5 is equal to A by B. Write this part in LHS, that is 2 root 5, write as it is, that is equal to A by B as it is. Now transfer this plus 3 from LHS to RHS, it becomes minus 3. Next, 2 root 5 is equal to A minus, take a cross multiplication here, 3B by B. Okay, A minus 3B by B. Next, root 5 is equal to A minus 3B by 2 comes here. In the denominator, it becomes 2B. So once again, in LHS, we know that root 5 is irrational. In RHS, A comma B comma A minus 3B by 2B are integers. So these things you have to write. If you forget to write, you won't get the marks. Integers and rational. Okay. LHS is irrational, RHS is rational. Our assumption is wrong. So if our assumption is wrong, the given question is correct. That is, hence 3 plus 2 root 5 is irrational. That is the correct one. Right, next question. Second one, prove that root p plus root q is an irrational where p comma q are primes. So let us follow the same method here. Let root p plus root q is rational. So if it is rational, according to the definition, root p plus root q is equal to a by b. So root p is equal to a by b minus root q, or root p is equal to a minus b root q, cross multiplication by b, squaring on both sides. That is, root p whole square is equal to a minus b root q whole square divided by b square. So square and root cancel. P is equal to a minus b root q whole square by b square. In the next step, we can write pb square is equal to a minus b root q whole square. So pb square is equal to, expand it, a minus b whole square, a square plus b square, that is b root q whole square minus 2a into b. So pb square is equal to a square plus b square into root q square minus 2 root q ab. So pb square is equal to, square and root cancel, a square plus qb square minus 2 root q ab. Now bring this minus 2 root q ab to the LHS, that is 2 root q ab is equal to a square plus qb square, and this pb square to RHS, that is minus pb square. So here we can write in LHS only root q, that is equal to a square plus q minus p into b square divided by 2ab. Okay, in LHS we know that root q is irrational. In RHS a comma b comma a square plus q minus p b square by 2ab are integers and rational. Therefore, our assumption is wrong. Hence, root p plus root q is an irrational. That is the proof of root p plus root q as irrational. Next, to do this question, evaluate 2 power 1. What is 2 power 1? So 2 power 1 is nothing but 2 only. So this is the answer. Next, second question, 4.73 whole power 0. So if you take whole power of any number or any variable, its value is 1 only. That is 4.73 whole power 0 is nothing but 1. Next, 0 cube, 0 into 0 into 0. So it is 0 only. 0 into 0, 0. 0 into 0 is 0. So 0 into 0 is also 0. Next, minus 1 whole power 4. That is minus 1 into 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 minus 1. So minus into minus plus, plus into minus minus, minus into minus plus. 1 ones are 1, 1 ones are 1, 1 ones are 1. So it is plus 1. Minus 1 whole power 4 is nothing but plus 1. Next, 0.25 whole power minus 1. So we can write that as 1 by 0.25. Next, 5 by 4 whole square. So 5 square by 4 square. It is nothing but 25 by 4 square is 16. Next, it is a mixed number or mixed fraction. 1 by 4 whole square. So 4 ones are 4 plus 1. So it is 5 by 4 whole square. That is equal to 5 square by 4 square. It is equal to 25 by 16. 5 square is 25 and 4 square is 16. Express 10, 100, 1000, 10,000, 1 lakh in exponential form. What is exponential form? For example, 2 into 2 into 2 into 2. Some numbers are there. So how can we write this? 2 power. How many 2's are there? 1, 2, 3, 4. 4 2's are there, no? Simply we can write that as 2 power 4. So this is called as exponential form. Okay. Now we have to write 10, 100, 1000, 10,000 and 1 lakh in that exponential form. So first I'll take 10. So 10 we can write as 10 power 1. Next 100. So 100 we can write that as 10 square. Okay, 100, 10, 1, 10 ones are 10 zeros or 10 ones are. So 100 is 10 square. Next to 1000. 1000 is 10 cube. Next to 10,000. 10 power 4. 1 lakh. So 1 lakh is 10 power 5. So this is the representation or expressing in exponential form. Next question from second bit B1, express the following products in simplest exponential form. So first in that first one 16 into 64. So take the prime factors of 16. 2 8s, 2 4s, 2 2s, 2 1s. In the same way 64. 2 3s are 2 2s are 2 1s are 2 6s are 2 8s are 2 4s are 2 2s are 2 1s are. So that is equal to, we can write 16 as 2 power, how many 2's? 1 2 3 4. 2 power 4 into 64. 1 2 3 4 5 6. So it is 2 power 6. When the bases are same, their powers must be added. That is equal to 2 power 4 plus 6. So it is equal to 2 power 10. Therefore, we can write 16 into 64 as simplest exponential form. That is 2 power 10. Next, second bit, B bit. In that second one, 25 into 125. 25 factors of 20 prime factors. 5 5s are, 5 1s are. Next 125. 5 twos are 10, 5 fives are 25, next 5 fives are 25, 5 ones are. So 25 into 125, that is equal to 25 is 5 square into 125 is 5, 1, 2, 3, 5 cube. So that is equal to, when the bases are same, their powers must be added. So here the bases are same, just you have to write only one base, then their powers must be added. Add the powers. So 5 power 5. So we have written 25 into 125 in the simplest exponential form. Next, third question in that. Right, 128 divided by 32. Third question, 128 divided by 32. 128 divided by 32. Take the factors, prime factors of 128. 2 6 are, 2 4s are, 2 3s are, 2 2s are, 2 1s are, 2 6 are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. Next 32. 2 1s are, 2 6 are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. So that is equal to 20, 128. 1, 2, 3, 4, 5, 6, 7. So it is 2 power 7 by 32. 1, 2, 3, 4, 5. 2 power 5. So here 1 5 and here 1 5. We can cancel. That is equal to. So what remains here? 2 power 2. That is 128 by 32 is equal to 2 power 2. So that is the simplest exponential form of 132 divided by 32. Right. Definition of logarithm. If a and n are positive real numbers, let us consider a and n are positive real numbers such that a is not equal to 1. Then log n. So we have to pronunciate like this: log n base a is equal to x implies and implied by a power x is equal to n. Okay. So this is the logarithm. Next, this is the exponential form. So it is logarithmic form and it is exponential form. So if the question is in logarithmic form, then we have to write into the exponential form. If the question is in exponential form, then we have to write into the logarithmic form. So definition of logarithm is nothing but log n base a is equal to x. If log n base a is equal to x, implies and implied by a power x is equal to n. Or if a power x is equal to n, then log n base a is equal to x. Okay, no? Right, students? Do this question in that. First one, write the following in logarithmic form. So first question is 7 is equal to 2 power x. The question is in the form of exponents. Now we have to write into the logarithmic form. So what is the definition of logarithms? If a power x is equal to n, then log n base a is equal to x. So this is the definition of logarithm. If the exponential form is given, then we have to change into the logarithm form. Okay. Now we are going to change that into the logarithm form. So what is the question? 7 is equal to 2 power x. So what I write? 2 power x is equal to some 7. Now observe here, what is a value? It is 2. What is n value? It is 7. And x value is x only. So you write here a is equal to 2, x is equal to x, and n is equal to 7. Okay. Then according to definition, what we have to write? We have to write in the logarithm form, that is log n base a is equal to x. No. So that implies log n. What is n value? 7. Base a value is 2. And that is equal to x value, x only. Therefore, we can write 2 power x is equal to 7. It is the exponential form, implies log 7 base 2 is equal to x. This is a logarithmic form. Next question, 5 power x is equal to 10. Now compare with the exponential form, a power x is equal to n. So where a value is 5. Next, x is x only and n value is 10. What is the logarithm form? log n base a is equal to x. So log n, what is n value? 10. Log 10 base a is 5 is equal to x is x only. Therefore, we can say that 5 power x is equal to 10. Then log 10 base 5 is equal to x. Next question, 100 is equal to 10 power x. Right, 10 power x is equal to 100. Now compare with the exponential form. A power x is equal to n. What is a value? A is equal to 10. X value, x is equal to x, and n value 100. Then what is the logarithmic form? Log n base a is equal to x. So now write log n. What is n value? 100. Base a value 10 is equal to x. X value is x only. Therefore, we can write 10 power x is equal to 100 implies log n, that is 100 base 10 is equal to x. Okay, students, this is the fourth question. Okay, students, I missed your third question. That is 1 by 81 is equal to 3 power c, or we may write that as 3 power c is equal to 1 by 81. Now compare with the coefficient exponential form. A power x is equal to n, where a is equal to 3 and x is equal to c. Next, n is equal to 1 by 81. Okay. Now logarithm form, log n base a is equal to x. So log n, what is n value? It is 1 by 81. Base a is 3. That is equal to x value, it is c. Therefore, we can write 3 power c is equal to 1 by 81 implies log 1 by 81 base 3 is equal to c. That is the answer. Next question, fifth question, 1 by 257 is equal to 4 power a. So 4 power a is equal to 1 by 257. Compare with the exponential form, a power x is equal to n, where a is equal to 4 and x is equal to a, and n is equal to 1 by 257. So write in the logarithm form, log n base a is equal to x. Log n, what is n value? 1 by 257, and base a, it is 4, is equal to x is a. Therefore, we can say that 4 power a is equal to 1 by 257 is equal to implies log 1 by 257 into base 4 is equal to a.